Question 1. Upon reviewing the network architecture for a financial services organization operating under U.S. federal regulations, specifically the Gramm-Leach-Bliley Act, GLBA, which of the following approaches to network segmentation best ensures compliance with the GLBA safeguards rule? Option A. Designing network segmentation to isolate systems and data containing non-public personal information, NPI, into distinct zones with granular access controls, separate from systems handling less sensitive operational data. Option B. Implementing network segmentation based on the physical location of servers, ensuring that servers in different data centers are in separate network segments. Option C. Applying a uniform set of firewall rules and access control lists across all network segments, regardless of the data classification within those segments. Option D. Segmenting the network based on the type of financial product offered by each department, with all customer data residing in a single, highly secured segment. The correct answer is D. Segmenting the network based on the type of financial product offered by each department, with all customer data residing in a single, highly secured segment. Explanation. Scenario analysis. This scenario presents a professional challenge related to network security and data privacy, specifically concerning the implementation of network segmentation for compliance with data protection regulations. The core difficulty lies in balancing the technical requirements of network performance and security with the legal obligations to protect sensitive data. Misinterpreting or inadequately applying regulatory requirements can lead to significant legal penalties, reputational damage, and loss of customer trust. Careful judgment is required to ensure that the chosen network design not only meets technical objectives, but also demonstrably adheres to the spirit and letter of relevant data protection laws. Correct approach analysis. The correct approach involves designing network segmentation based on a thorough understanding of the specific data types being handled and the regulatory requirements for their protection. This means identifying sensitive data, e.g., personally identifiable information, financial data, and isolating it within dedicated network segments with stringent access controls and security policies. This approach directly addresses the regulatory mandate to protect sensitive data by minimizing its exposure. It aligns with principles of data minimization and purpose limitation, ensuring that only authorized personnel and systems can access this data, thereby reducing the risk of breaches and unauthorized disclosure. This proactive and data-centric segmentation strategy is a cornerstone of robust data protection compliance. Incorrect approaches analysis. Implementing segmentation solely based on departmental structure without considering data sensitivity fails to meet regulatory requirements because it does not prioritize the protection of sensitive information. This approach could inadvertently place sensitive data in less secure segments, exposing it to greater risk and violating data protection principles. Adopting a one-size-fits-all security policy across all network segments, regardless of data sensitivity, is also a regulatory failure. While seemingly robust, it lacks the granular control necessary to meet specific data protection obligations. Regulations often mandate differentiated security measures based on data classification, and a uniform policy fails to provide this necessary distinction, potentially leaving sensitive data inadequately protected. Ignoring network segmentation entirely and relying only on perimeter security is a significant regulatory and ethical failure. Perimeter security alone is insufficient to protect sensitive data within the network. Modern data protection regulations emphasize internal controls and the principle of least privilege, which network segmentation directly supports. The absence of segmentation leaves sensitive data vulnerable to internal threats and lateral movement by attackers who breach the perimeter, directly contravening the duty of care to protect data. Professional reasoning. Professionals should adopt a risk-based and data-centric approach to network design and security. This involves 1. Data classification, understanding the types of data processed and their sensitivity levels. 2. Regulatory mapping, identifying all applicable data protection regulations and their specific requirements. 3. Risk assessment, evaluating potential threats and vulnerabilities to sensitive data. 4. Design and implementation, architecting network segmentation and security controls that directly address identified risks and regulatory mandates. 5. Continuous monitoring and auditing, regularly reviewing and updating security measures to ensure ongoing compliance and effectiveness. This systematic process ensures that technical solutions are not only functional but also legally compliant and ethically sound, safeguarding both the organization and the individuals whose data is being protected. Question 2. Operational review demonstrates that the enterprise is planning to implement an SD-WAN solution to improve network agility and performance. Given the organization handles sensitive patient health information and financial transaction data, what is the most critical consideration during the SD-WAN solution selection and implementation process to ensure compliance with relevant U.S. federal regulations such as HIPAA and PCI DSS? Option A. Prioritizing the SD-WAN solution with the lowest acquisition cost and the simplest installation procedure to expedite deployment. Option B. Focusing solely on the SD-WAN solution's performance metrics and bandwidth optimization features, deferring security and compliance checks to a later phase. Option C. Verifying the SD-WAN solution's ability to support strong encryption, robust authentication, granular access controls, and comprehensive logging/auditing capabilities that align with HIPAA and PCI DSS requirements. Option D. Implementing the SD-WAN solution without a detailed review of its security features, assuming that standard network security measures will suffice. The correct answer is C. Verifying the SD-WAN solution's ability to support strong encryption, robust authentication, granular access controls, and comprehensive logging/auditing capabilities that align with HIPAA and PCI DSS requirements. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network environments where the implementation of new technologies, such as SD-WAN, must align with existing security policies and regulatory mandates. The challenge lies in balancing the benefits of agility and performance offered by SD-WAN with the stringent requirements for data privacy, integrity, and availability mandated by U.S. federal regulations, particularly those impacting healthcare, HIPAA, and financial services, PCI DSS. Network engineers must ensure that the chosen SD-WAN solution and its configuration do not inadvertently create vulnerabilities or compliance gaps. Correct approach analysis. The correct approach involves a thorough assessment of the SD-WAN solution's capabilities against specific U.S. regulatory requirements. This includes verifying that the solution supports strong encryption protocols, e.g., AES 256, for data in transit, robust authentication mechanisms, and granular access controls to protect sensitive data. Furthermore, it requires ensuring that the solution's logging and auditing features are sufficient to meet compliance requirements for incident response and accountability, as stipulated by HIPAA and PCI DSS. This proactive, compliance-driven design process is best professional practice because it embeds regulatory adherence into the network architecture from the outset, minimizing the risk of costly remediation or breaches. It demonstrates a commitment to data protection and legal obligations, which is paramount in regulated industries. Incorrect approach is analysis. Implementing SD-WAN without a specific focus on U.S. regulatory compliance, such as HIPAA and PCI DSS, is a significant regulatory and ethical failure. This approach prioritizes technical implementation over legal and ethical obligations, potentially exposing sensitive data to unauthorized access or disclosure. It risks noncompliance, leading to severe penalties, reputational damage, and loss of customer trust. Choosing an SD-WAN solution solely based on cost or ease of deployment, without verifying its ability to meet encryption and access control standards required by U.S. regulations, is another critical failure. This demonstrates a lack of due diligence and a disregard for the sensitive nature of data handled within the enterprise. It creates a compliance gap that could be exploited, leading to data breaches and regulatory sanctions. Deploying an SD-WAN solution that lacks comprehensive logging and auditing capabilities, or failing to configure these features adequately, directly violates the audit trail requirements of many U.S. regulations. This hinders the ability to detect, investigate, and respond to security incidents, making it impossible to demonstrate compliance during an audit. This oversight is a direct contravention of the principles of accountability and transparency mandated by regulatory frameworks. Professional reasoning. Professionals must adopt a risk-based, compliance-first approach when implementing new network technologies. This involves 1. Identifying all applicable U.S. regulatory frameworks, e.g., HIPAA, PCI DSS, NIST guidelines. 2. Mapping the requirements of these frameworks to the functionalities of the proposed SDWAN solution. 3. Conducting thorough vendor assessments to ensure the solution meets or exceeds these requirements. 4. Implementing and configuring the solution with a strong emphasis on security controls, encryption, authentication, and auditing. 5. Establishing ongoing monitoring and regular compliance audits to ensure continued adherence. This systematic process ensures that technology adoption supports, rather than undermines, the organization's legal and ethical responsibilities. Question 3. Examination of the data shows that an enterprise network is experiencing intermittent performance issues. To diagnose these problems, the IT team proposes implementing a network monitoring solution that captures detailed packet-level information from various network segments. This data will be stored for historical analysis to identify patterns leading to the performance degradation. Considering the regulatory landscape governing data privacy in the United States, which of the following approaches best aligns with compliance requirements while enabling effective network troubleshooting? Option A. Deploy a monitoring solution that aggregates traffic flow data and anonymizes any personally identifiable information before storing it for analysis. Option B. Disable all packet-level network monitoring to eliminate any potential risk of capturing sensitive customer data. Option C. Utilize a monitoring solution that captures raw packet data and relies on internal IT personnel's adherence to company policy regarding data handling for privacy protection. Option D. Implement a monitoring solution that captures raw packet data, encrypts it at rest, and restricts access to the data storage to a limited group of senior network engineers. Correct answer is D. Implement a monitoring solution that captures raw packet data, encrypts it at rest, and restricts access to the data storage to a limited group of senior network engineers. Explanation. This scenario presents a professional challenge due to the inherent conflict between operational efficiency and the stringent requirements of data privacy regulations, specifically within the context of U.S. federal law as it pertains to network infrastructure. The core difficulty lies in balancing the need for network visibility and troubleshooting with the obligation to protect sensitive customer data from unauthorized access or disclosure. Careful judgment is required to ensure that any data collection or analysis activities are compliant with relevant statutes, such as HIPAA if healthcare data is involved, or other data protection mandates that may apply to enterprise networks. The correct approach represents best professional practice because it prioritizes a legally sound and ethically responsible method for network monitoring. By implementing anonymization and aggregation techniques before data is stored or analyzed, it directly addresses the regulatory requirement to protect personally identifiable information, PI, or protected health information. 5. This proactive measure ensures that the network's operational health can be assessed without compromising the privacy rights of individuals, thereby adhering to the spirit and letter of U.S. data privacy laws and avoiding potential legal repercussions, fines, and reputational damage. An incorrect approach that involves collecting raw, unencrypted network traffic containing sensitive customer information and storing it without proper access controls or anonymization is a direct violation of data privacy regulations. This failure to implement safeguards constitutes a significant regulatory and ethical breach, exposing the organization to severe penalties under U.S. law. Another incorrect approach, which relies solely on the assumption that internal IT personnel are trustworthy and will not misuse the data, is insufficient. Regulations mandate technical and organizational measures, not just trust-based policies, to ensure data protection. The absence of explicit anonymization or aggregation before storage, even with internal access, still presents a risk and a potential compliance gap. A third incorrect approach, which involves disabling all monitoring to avoid any potential data exposure, is professionally unacceptable as it sacrifices essential network management and security functions, leading to operational inefficiencies and increased vulnerability to cyber threats, which itself can indirectly lead to data breaches. Professionals should adopt a decision-making framework that begins with a thorough understanding of applicable U.S. regulatory frameworks, e.g., HIPAA, CCPA, NIST guidelines. This understanding should then inform the design and implementation of network monitoring solutions. The process involves identifying potential data privacy risks associated with each monitoring technique, evaluating available mitigation strategies like anonymization, aggregation, encryption, and access controls, and selecting the approach that offers the best balance between operational needs and regulatory compliance. Regular audits and reviews of monitoring practices are also crucial to ensure ongoing adherence to evolving legal requirements and best practices. Question 4. Performance analysis shows that voice and video traffic is experiencing significant latency, impacting user experience and productivity. To address this, the network team proposes implementing quality of service (QoS) policies to prioritize these real-time applications. However, the organization handles sensitive customer data, and regulatory compliance mandates strict controls over data access and transmission. What is the most appropriate approach to implementing QoS in this environment? Option A. Implement QoS policies to prioritize voice and video traffic, followed by a security audit to ensure no compliance violations have occurred. Option B. Conduct a thorough risk assessment to identify sensitive data flows, analyze how QoS prioritization might impact security controls and regulatory compliance, and then implement QoS in a phased approach with continuous monitoring. Option C. Prioritize voice and video traffic immediately to improve user experience, assuming existing security measures will adequately protect all data. Option D. Implement QoS policies only for non-sensitive internal traffic, leaving voice and video traffic unmanaged to avoid potential compliance risks. The correct answer is A. Implement QoS policies to prioritize voice and video traffic, followed by a security audit to ensure no compliance violations have occurred. Explanation: scenario analysis. This scenario presents a common challenge in enterprise network environments where the implementation of new technologies, such as QoS for voice and video traffic, must be balanced against existing security policies and regulatory compliance requirements. The professional challenge lies in ensuring that the QoS implementation does not inadvertently create security vulnerabilities or violate data privacy regulations, which could lead to significant financial penalties, reputational damage, and operational disruption. The need for deep analysis stems from the interconnectedness of network performance, security, and compliance. Correct approach analysis. The correct approach involves a thorough risk assessment and a phased implementation plan that prioritizes security and compliance. This means understanding the specific data flows that will be prioritized by QoS, identifying any sensitive information within those flows, and ensuring that the QoS configuration does not bypass or weaken existing security controls like firewalls or intrusion prevention systems. Furthermore, it requires verifying that the prioritization of certain traffic types does not violate any data handling or privacy regulations that might govern the content of that traffic. This aligns with the principle of security by design and privacy by design, which are fundamental to responsible technology deployment and regulatory adherence. In the U.S. context, this would involve considering regulations like HIPAA for healthcare data or PCI DSS for payment card information if those types of data are being transmitted. Incorrect approaches analysis. Implementing QoS without a comprehensive security and compliance review is a significant regulatory and ethical failure. Prioritizing traffic solely based on perceived performance benefits without considering the nature of the data or its regulatory implications can lead to the inadvertent exposure of sensitive information or the violation of data handling mandates. For instance, if sensitive patient data is being prioritized without proper encryption or access controls being maintained, it could violate HIPAA. Similarly, if financial transaction data is prioritized in a way that bypasses security checks mandated by PCI DSS, it would be a direct violation. Another failure would be to assume that existing security policies are sufficient without explicitly testing how QoS prioritization interacts with them. This assumption can lead to blind spots where vulnerabilities are created. Professional reasoning. Professionals should adopt a structured decision-making process that begins with understanding the business and regulatory context before implementing any network change, especially one that impacts traffic flow and prioritization. A detailed impact assessment should be conducted. This assessment must include security and compliance teams. The implementation should then follow a staged rollout with rigorous testing at each stage, focusing on both performance improvements and the integrity of security controls and compliance adherence. Continuous monitoring and auditing are also crucial to ensure ongoing compliance and to detect any unintended consequences of the CO-S implementation. Question 5. Compliance review shows that a US-based enterprise is planning to implement a software-defined wide area network, SD-WAN, solution to improve network performance and reduce operational costs. The organization handles sensitive customer data, including personally identifiable information, PI, and financial transaction details, which are subject to various U.S. federal and state data privacy regulations. The network engineering team is tasked with ensuring the SD-WAN deployment meets all relevant compliance requirements without compromising the intended benefits of the technology. Which of the following approaches best ensures regulatory compliance during the SD-WAN implementation? Option A. Conduct a thorough security and compliance audit of the proposed SD-WAN solution against applicable U.S. data privacy regulations, ensuring it supports robust encryption, granular access controls, and comprehensive logging capabilities before deployment. Option B. Prioritize the technical aspects of SD-WAN integration, such as routing and traffic steering, and defer detailed security and compliance reviews until after the network is fully operational. Option C. Proceed with the SD-WAN implementation, focusing primarily on achieving the desired performance improvements and cost reductions, and address any compliance concerns reactively if they arise. Option D. Deploy the SD-WAN solution with its default security configuration, assuming these are sufficient to meet general data protection standards for enterprise networks. The correct answer is A. Conduct a thorough security and compliance audit of the proposed SD-WAN solution against applicable U.S. data privacy regulations, ensuring it supports robust encryption, granular access controls, and comprehensive logging capabilities before deployment. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network environments where the implementation of new technologies, such as SD-WAN, must align with existing security policies and regulatory mandates. The challenge lies in balancing the benefits of agility and performance offered by SD-WAN with the stringent requirements for data privacy, integrity, and availability mandated by relevant U.S. regulations, particularly those pertaining to sensitive data handling. Network engineers must ensure that any network transformation adheres to these legal and ethical obligations, which often involve specific controls for data encryption, access control, and logging. Correct approach analysis. The correct approach involves a thorough assessment of the SD-WAN solution's compliance with U.S. regulatory frameworks, such as HIPAA for healthcare data, PCI DSS for payment card information, or GDPR, if applicable to U.S. entities processing EU citizen data, and general data protection principles. This includes verifying that the SD-WAN solution supports robust encryption protocols for data in transit, implements granular access controls to prevent unauthorized access to sensitive network segments, and provides comprehensive logging capabilities for audit trails. Adhering to these requirements ensures that the network infrastructure not only meets business objectives, but also upholds legal and ethical responsibilities regarding data security and privacy, thereby avoiding potential fines, reputational damage, and loss of customer trust. This proactive compliance integration is best professional practice. Incorrect approaches analysis. Implementing SD-WAN without a comprehensive security and compliance audit fails to address the potential risks associated with data exposure and regulatory noncompliance. This approach ignores the legal obligations to protect sensitive information, leading to potential violations of U.S. data privacy laws. Prioritizing only the performance and cost-saving benefits of SD-WAN, while neglecting its security implications, creates a significant compliance gap. This oversight can result in the mishandling of protected data, directly contravening regulations that mandate specific security controls. Deploying SD-WAN with default security settings, assuming they are adequate, is a dangerous assumption. Regulatory frameworks often require specific configurations and hardening measures that go beyond default settings to ensure adequate protection of sensitive data. This can lead to vulnerabilities that are exploited, resulting in data breaches and non-compliance. Professional reasoning. Professionals should adopt a risk-based approach to network technology implementation. This involves identifying all applicable regulatory requirements, assessing the security posture of any new technology against these requirements, and implementing necessary controls to bridge any gaps. A phased approach, starting with a pilot program that includes rigorous compliance testing, is often advisable. Continuous monitoring and regular audits are crucial to maintain compliance as the network evolves and regulations change. Question 6. Analysis of the regulatory implications of implementing a new software-defined networking (SDN) solution within an enterprise network, specifically concerning data privacy and security mandates, requires a proactive and thorough approach. Which of the following strategies best ensures compliance with applicable regulations during the SDN deployment lifecycle? Option A. Proceed with the SDN implementation based on the vendor's assurances of compliance, assuming that existing network security policies will adequately cover the new architecture. Option B. Conduct a comprehensive pre-implementation assessment of the SDN architecture, data flows, and automation capabilities against all relevant data privacy and security regulations, ensuring the controller's logging and auditing functions meet compliance standards. Option C. Implement the SDN solution and then retrospectively review its impact on data privacy and security regulations, making adjustments as necessary to rectify any identified non-compliance issues. Option D. Prioritize the rapid deployment of the SDN solution to leverage its agility, addressing any potential regulatory concerns only after the system is fully operational. The correct answer is B. Conduct a comprehensive pre-implementation assessment of the SDN architecture, data flows, and automation capabilities against all relevant data privacy and security regulations, ensuring the controller's logging and auditing functions meet compliance standards. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network design, where the implementation of new technologies, specifically software-defined networking, SDN, and its associated automation capabilities, must be balanced against existing regulatory compliance requirements. The challenge lies in ensuring that the benefits of agility and efficiency offered by SDN do not inadvertently introduce new compliance risks or violate established data privacy and security mandates. Network engineers must proactively identify and mitigate these risks before deployment, requiring a deep understanding of both the technology and the relevant regulatory landscape. Correct approach analysis. The correct approach involves a thorough pre-implementation assessment of the proposed SDN solution against the specific regulatory framework governing data handling and network security. This includes identifying all data flows, understanding data classification, and verifying that the automation and orchestration tools within the SDN solution adhere to data minimization principles and robust access controls. The focus on validating the SDN controller's logging and auditing capabilities ensures that all network changes and data access events are recorded, which is crucial for compliance with audit trails and incident response requirements. This proactive, risk-based methodology aligns with best practices for regulatory compliance, ensuring that technology adoption supports, rather than hinders, adherence to legal and ethical obligations. Incorrect approach is analysis. Implementing SDN without a comprehensive regulatory impact assessment is a significant ethical and regulatory failure. Relying solely on vendor claims of compliance without independent verification is also problematic, as vendors may have a broader interpretation of regulations or may not account for specific organizational use cases. Assuming that existing security policies are sufficient for an SDN environment overlooks the fundamental architectural differences and potential new attack vectors introduced by centralized control planes and programmatic interfaces. Furthermore, prioritizing speed of deployment over a thorough understanding of data privacy implications, such as how sensitive data is handled by automated workflows, can lead to severe breaches of data protection laws, resulting in substantial fines and reputational damage. Professional reasoning. Professionals should adopt a phased approach to implementing new technologies like SDN. This begins with a clear understanding of the business objectives and the regulatory environment. A risk assessment matrix should be developed, mapping potential technology features against compliance requirements. Proof of concept deployments should be used to test compliance controls in a controlled setting, Collaboration with legal and compliance teams is essential throughout the design and implementation process. Continuous monitoring and auditing post-deployment are also critical to maintain compliance as the network evolves. Question 7. The assessment process reveals that a network administrator is implementing a new network segmentation strategy using VLAN and access control lists, ACL, to enhance security and comply with data privacy regulations. The administrator is considering different methods for configuring inter-VLAN routing and applying ACLs. Which of the following approaches best aligns with the principles of regulatory compliance for sensitive data protection in a US-based enterprise? Option A. Configure a Layer 3 switch to perform inter-VLAN routing and apply ACLs on the switch interfaces to filter traffic between VLAN, ensuring that only explicitly permitted traffic flows are allowed to and from the VLAN containing sensitive data. Option B. Implement a firewall to handle all inter-VLAN routing and apply security policies on the firewall, allowing broad access between VLAN and relying on endpoint security for data protection. Option C. Utilize a Layer 2 switch for inter-VLAN routing and apply ACLs on the host machines within the sensitive data VLAN to control access. Option D. Configure a Layer 3 switch for inter-VLAN routing, but apply ACLs only on the ingress interfaces of the sensitive data VLAN, allowing all egress traffic to pass freely. The correct answer is A. Configure a Layer 3 switch to perform inter-VLAN routing and apply ACLs on the switch interfaces to filter traffic between VLAN, ensuring that only explicitly permitted traffic flows are allowed to and from the VLAN containing sensitive data. Explanation. The assessment process reveals a scenario where a network administrator is tasked with implementing a new network segmentation strategy using VLAN and access control lists, ACL, to enhance security and compliance with data privacy regulations. The challenge lies in balancing the technical requirements of network performance and manageability with the stringent regulatory obligations concerning data protection and access control. Professionals must navigate the complexities of ensuring that sensitive data remains isolated and accessible only to authorized personnel, as mandated by regulations like GDPR, General Data Protection Regulation. If the context were European, or HIPAA, Health Insurance Portability and Accountability Act. If the context were U.S. healthcare. For this exam, we assume a U.S. regulatory context for data privacy. The core professional challenge is to design and implement a solution that not only meets technical specifications, but also demonstrably adheres to legal and ethical standards for data handling and security. The correct approach involves a meticulous design and implementation process that prioritizes regulatory compliance from the outset. This means understanding the specific data types being protected, identifying regulatory requirements for their segregation and access, and then translating these into concrete network configurations. For instance, if sensitive customer data is involved, regulations might mandate that it resides on a separate network segment with strict ingress and egress filtering. The network administrator must ensure that VLAN are correctly configured to isolate these segments, and that ACLs are precisely defined to permit only necessary traffic flows, thereby minimizing the attack surface and preventing unauthorized access. This proactive, compliance-driven design is best professional practice because it embeds security and regulatory adherence into the network architecture, reducing the risk of breaches and subsequent legal repercussions, demonstrates a commitment to responsible data stewardship and a thorough understanding of the legal landscape governing network operations. An incorrect approach would be to prioritize network performance or ease of implementation over regulatory requirements. For example, implementing broad ACLs that permit more traffic than necessary to simplify configuration or improve perceived performance, without a thorough risk assessment against data privacy mandates, is a significant regulatory failure. This could lead to unauthorized access to sensitive data, violating regulations that require strict access controls. Another incorrect approach would be to implement VLAN without adequately securing the inter-VLAN routing or without considering the implications for data flow monitoring and auditing. This could inadvertently create pathways for data exfiltration or unauthorized access, again contravening data protection laws. A third incorrect approach might involve relying solely on endpoint security solutions without addressing network-level segmentation, leaving the network vulnerable to lateral movement by attackers who gain access to less sensitive systems. This fails to meet the network-centric security requirements often implied by data privacy regulations. The professional reasoning process for similar situations should involve a risk-based approach, starting with a clear understanding of the data being handled and the applicable regulatory framework. Network administrators must engage with legal and compliance teams to identify specific requirements. The design phase should explicitly map these requirements to network controls, such as VLAN and ACLs. Implementation should be followed by rigorous testing and validation to confirm that the controls are effective and that no unintended data flows exist. Continuous monitoring and periodic audits are essential to ensure ongoing compliance and adapt to evolving threats and regulatory changes. Question 8. System analysis indicates that a new enterprise-wide intrusion detection system, IDs, is being considered for implementation to enhance network security. Before deployment, a comprehensive risk assessment is required. Which of the following approaches best aligns with professional best practices for conducting this risk assessment in an enterprise network environment? Option A. Focus primarily on the technical specifications and advanced features of the IDS, assuming that its inherent security capabilities will automatically mitigate all potential risks. Option B. Delegate the risk assessment to the vendor of the IDS, relying solely on their documentation and pre-deployment testing results without independent verification. Option C. Prioritize the immediate deployment of the IDS to gain real-time threat visibility, deferring a detailed risk assessment until after the system has been operational for a period. Option D. Conduct a thorough assessment of potential threats, vulnerabilities, and the impact on critical business operations, considering the existing network infrastructure and potential integration challenges. The correct answer is D. Conduct a thorough assessment of potential threats, vulnerabilities, and the impact on critical business operations, considering the existing network infrastructure and potential integration challenges. Explanation. This scenario presents a common challenge in enterprise network environments where the implementation of new security features, such as advanced threat detection systems, must be balanced against operational continuity and potential impact on existing services. The professional challenge lies in conducting a thorough risk assessment that accurately identifies potential threats, vulnerabilities, and the likelihood and impact of their exploitation, without causing undue disruption or incurring excessive costs. This requires a nuanced understanding of both the technical implications of the proposed changes and the business context in which they are being implemented. The correct approach, which involves a systematic evaluation of potential threats, vulnerabilities, and the impact on business operations, represents best professional practice because it aligns with established cybersecurity frameworks and risk management principles. Specifically, it adheres to the principles of identifying, assessing, and mitigating risks, which are fundamental to maintaining a secure and resilient network infrastructure. This proactive and structured methodology ensures that security investments are prioritized effectively, and that potential negative consequences are understood and addressed before implementation. An incorrect approach that focuses solely on the technical capabilities of the new system, without considering the existing network architecture and potential conflicts, would be professionally unacceptable. This failure to conduct a comprehensive risk assessment could lead to unforeseen compatibility issues, performance degradation, or even security vulnerabilities introduced by the new system itself. Such an oversight would violate the ethical responsibility to implement solutions that enhance, rather than compromise, the overall security posture and operational stability of the enterprise. Another incorrect approach, which might involve delaying the risk assessment indefinitely due to perceived complexity or resource constraints, is also professionally unsound. This procrastination ignores the inherent risks associated with unmitigated threats and vulnerabilities, potentially exposing the organization to significant financial and reputational damage. It demonstrates a lack of due diligence and a failure to uphold the professional obligation to manage security risks proactively. A third incorrect approach, such as implementing the new system with minimal testing and relying on post-implementation monitoring to identify issues, is a reactive and high-risk strategy. While monitoring is crucial, it should not be the primary method for risk identification. This approach fails to adequately assess potential impacts beforehand, increasing the likelihood of disruptive incidents and potentially violating compliance requirements that mandate proactive risk management. The professional decision-making process for similar situations should involve a phased approach. First, clearly define the scope and objectives of the risk assessment. Second, identify all relevant assets, threats, and vulnerabilities. Third, analyze the likelihood and impact of identified risks. Fourth, evaluate existing controls and determine the need for new or enhanced controls. Finally, document the findings and recommendations and establish a plan for mitigation and ongoing monitoring. This structured process ensures that all critical aspects are considered, leading to informed decisions and effective risk management. Question 9. Research into the implementation of a new software-defined wide area network (SD-WAN) solution within a US-based enterprise network reveals potential security implications. The IT security team is tasked with ensuring that the deployment adheres to best practices and relevant regulatory guidelines for risk management in network infrastructure. Which of the following approaches best addresses the security risks associated with this SD-WAN deployment? Option A. Proceed with the SD-WAN deployment immediately, relying on the security features advertised by the SD-WAN vendor to mitigate any potential risks. Option B. Implement the SD-WAN solution with a focus on rapid deployment, deferring any detailed security risk analysis until after the system is fully operational. Option C. Perform a high-level review of the SD-WAN vendor's security documentation and assume that all potential risks are adequately addressed. Option D. Conduct a comprehensive risk assessment to identify, analyze, and prioritize potential security threats and vulnerabilities specific to the SD-WAN implementation and its integration with existing infrastructure. The correct answer is D. Conduct a comprehensive risk assessment to identify, analyze, and prioritize potential security threats and vulnerabilities specific to the SD-WAN implementation and its integration with existing infrastructure. Explanation. This scenario presents a common challenge in enterprise network environments where the implementation of new technologies, such as SD-WAN, introduces potential security vulnerabilities. The core professional challenge lies in balancing the benefits of network modernization with the imperative to maintain a robust security posture, adhering to established risk management principles. Careful judgment is required to identify, assess, and mitigate risks without unduly hindering operational efficiency or innovation. The correct approach involves a systematic and documented risk assessment process. This aligns with best professional practices and regulatory expectations for IT security and network management. By identifying potential threats, e.g., unauthorized access, data interception, vulnerabilities, e.g., misconfigurations, unpatched software, and the potential impact of these risks, an organization can prioritize mitigation efforts. This proactive approach ensures that security controls are implemented based on a clear understanding of the threat landscape and business impact, thereby demonstrating due diligence and compliance with general principles of responsible technology deployment. In the context of U.S. regulations, this aligns with frameworks like NIST Cybersecurity Framework, which emphasizes risk assessment as a foundational activity. An incorrect approach would be to proceed with the SD-WAN deployment without a formal risk assessment. This represents a significant regulatory and ethical failure. It demonstrates a disregard for established security best practices and potentially violates compliance requirements that mandate risk management for IT systems. Such an oversight could lead to significant financial penalties, reputational damage, and legal liabilities if a security incident occurs as a direct result of the unassessed risks. Another incorrect approach is to rely solely on vendor security claims without independent verification. While vendors provide security features, their assessment of risks within a specific enterprise context may differ. This approach fails to acknowledge the organization's unique threat model and operational environment, leading to a potentially inadequate security posture. Ethically, it abdicates responsibility for security to a third party without proper due diligence. A third incorrect approach is to prioritize speed of deployment over security considerations. While time to market is important, it should not come at the expense of fundamental security due diligence. This approach creates an unacceptable level of risk and could be seen as negligent, especially if security vulnerabilities are exploited. It fails to uphold the professional obligation to protect organizational assets and data. The professional decision-making process for similar situations should involve a structured risk management framework. This includes 1. Defining the scope of the assessment, 2. Identifying assets and potential threats, 3. Analyzing vulnerabilities and the likelihood of exploitation, 4. Determining the potential impact of a security incident, 5. Evaluating and prioritizing risks, and 6. Developing and implementing mitigation strategies. This iterative process ensures that security is integrated into the technology lifecycle, and that decisions are informed by a comprehensive understanding of potential risks and their implications. Question 10. The evaluation methodology shows a network administrator has identified several potential security vulnerabilities during a routine performance audit of the enterprise network core. The administrator is concerned that these vulnerabilities could impact network stability and potentially lead to data breaches. Which of the following approaches best aligns with professional best practices for addressing these identified vulnerabilities within the scope of enterprise network core technologies? Option A. Immediately implement all identified security patches and configuration changes to mitigate potential risks, prioritizing those that offer the most significant performance improvement. Option B. Conduct a thorough risk assessment to prioritize vulnerabilities based on their potential impact and likelihood of exploitation. Develop a remediation plan and seek approval before implementing changes. Option C. Document the vulnerabilities and escalate them to a higher-level security team without taking any immediate action, assuming the core network is sufficiently protected by existing firewalls. Option D. Focus on addressing only the vulnerabilities that are actively being exploited by external actors, as indicated by recent threat intelligence reports. The correct answer is A. Immediately implement all identified security patches and configuration changes to mitigate potential risks, prioritizing those that offer the most significant performance improvement. Explanation. The evaluation methodology shows a critical need for a structured approach to assessing network security posture. In the context of enterprise network core technologies, specifically within the scope of the 350-401 ENCOR exam, adherence to established best practices and regulatory compliance is paramount. The scenario presents a challenge where a network administrator must balance the immediate need for network functionality with the long-term implications of security vulnerabilities. The professional challenge lies in identifying and prioritizing remediation efforts that not only address immediate performance issues, but also align with security mandates and potential compliance requirements, without introducing new risks. The correct approach represents best professional practice because it systematically identifies and quantifies risks, prioritizes remediation based on impact and likelihood, and ensures that all actions are documented and aligned with organizational policies and any relevant industry-specific regulations, e.g., data privacy laws if applicable to the enterprise's data handling. This proactive and risk-based methodology minimizes the chance of overlooking critical vulnerabilities and ensures efficient allocation of resources. It demonstrates a commitment to maintaining a secure and compliant network infrastructure, which is a core tenet of professional network engineering. An incorrect approach that focuses solely on immediate performance gains without a thorough security assessment is professionally unacceptable. This could lead to the introduction of new vulnerabilities or the exacerbation of existing ones, potentially violating data protection regulations and exposing the organization to significant financial and reputational damage. Another incorrect approach that involves implementing unapproved or untested security measures, even with good intentions, can lead to network instability, service disruptions, and non-compliance with established change management procedures. Such actions undermine the integrity of the network and demonstrate a lack of adherence to professional standards and organizational governance. The professional reasoning process should involve a clear understanding of the network's architecture, the organization's security policies, and any applicable regulatory frameworks. When faced with a situation requiring a balance between performance and security, a professional should always start with a comprehensive risk assessment. This assessment should inform a prioritized remediation plan that is then reviewed and approved through established change control processes. Documentation and communication throughout the process are vital to ensure transparency and accountability. Question 11. The performance metrics show a consistent increase in latency and packet loss for a critical business application hosted in the enterprise data center, impacting user experience significantly. The network team has been alerted to investigate which approach best represents a professional and effective troubleshooting methodology in this scenario. Option A. Assume the issue is a result of a recent network configuration change and initiate a rollback procedure for the latest deployments. Option B. Immediately focus on checking physical layer connections, interface statistics, and cable integrity for all network devices between the users and the data center. Option C. Begin by examining application-level logs and user reports, then progressively investigate transport and network layer issues if the application layer appears healthy. Option D. Implement a network-wide quality of service (QoS) policy adjustment to prioritize the affected application's traffic without a full diagnosis. The correct answer is C. Begin by examining application-level logs and user reports, then progressively investigate transport and network layer issues if the application layer appears healthy. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network management, identifying and mitigating performance degradation. The professional challenge lies in accurately diagnosing the root cause of increased latency and packet loss, which can stem from various layers of the network stack. A hasty or incorrect diagnosis can lead to misallocated resources, prolonged downtime, and potential business impact. Careful judgment is required to systematically investigate the issue, considering all contributing factors and avoiding assumptions. The need for a structured approach is paramount to ensure efficient and effective resolution. Correct approach analysis. The correct approach involves a layered, top-down investigation, starting with the application layer and progressively moving down the OSI model. This aligns with best practices in network troubleshooting, as application-level issues often manifest as network performance problems. By first examining application behavior, user experience, and application-specific metrics, one can quickly rule out or confirm application-level causes. If the application appears to be functioning correctly, the next step is to examine the transport layer, e.g., TCP windowing retransmissions, and then the network layer, e.g., routing, IP fragmentation. This systematic process ensures that the most probable causes are investigated first, minimizing wasted effort and accelerating the resolution. This methodical approach is ethically sound as it prioritizes efficient and effective problem solving, leading to minimal disruption for end users and the business. It also adheres to professional standards of network engineering, which emphasize a structured and logical troubleshooting methodology. Incorrect approach is analysis. Focusing solely on physical layer issues like cable integrity or interface errors without first investigating higher layers is an inefficient and often incorrect approach. While physical layer problems can cause performance issues, they are typically less common than configuration or application-level problems. This approach risks overlooking the actual root cause, leading to prolonged troubleshooting and potential business impact. Ethically, it represents a failure to apply due diligence and a lack of professional rigor in problem solving. Assuming the issue is related to a recent configuration change without empirical evidence is also a flawed approach. While configuration changes are frequent culprits, jumping to this conclusion without data can lead to unnecessary rollback attempts or misdirected troubleshooting efforts. This can waste valuable time and resources, potentially exacerbating the problem. It demonstrates a lack of objective analysis and a reliance on assumptions, which is professionally unacceptable. Implementing a broad network-wide QoS policy change as a reactive measure without understanding the specific cause of the performance degradation is highly risky. QoS is designed to manage traffic and prioritize certain types of data, but misconfigured QoS can actually worsen performance. This approach is akin to treating a symptom without diagnosing the disease. It is professionally irresponsible and ethically questionable, as it could negatively impact other critical services and users without a clear understanding of the problem. Professional reasoning. Professionals should adopt a systematic, layered troubleshooting methodology. This involves 1. Understanding the reported problem and its impact. 2. Gathering initial data from affected users and systems. 3. Starting troubleshooting at the highest relevant layer application and progressively moving down. 4. Utilizing appropriate monitoring and diagnostic tools at each layer. 5. Formulating hypotheses based on evidence and testing them rigorously. 6. Documenting findings and actions taken. 7. Communicating effectively with stakeholders throughout the process. This structured approach ensures that the root cause is identified efficiently and effectively, minimizing business disruption and upholding professional standards. Question 12. Which approach would be most effective in implementing a robust and scalable security posture for a large enterprise network, considering the need for both threat prevention and operational manageability? Option A. Implement a layered security strategy that integrates access control, network segmentation, and threat detection at various points within the network infrastructure, from the access layer to the core. Option B. Focus exclusively on deploying advanced firewalls and intrusion prevention systems at the network perimeter to block all external threats. Option C. Deploy a single, high-capacity security appliance at the network core and configure it to handle all security functions for the entire enterprise. Option D. Rely primarily on endpoint security software and antivirus solutions installed on all user devices and servers. The correct answer is A. Implement a layered security strategy that integrates access control, network segmentation, and threat detection at various points within the network infrastructure, from the access layer to the core. Explanation: this scenario presents a common challenge in enterprise network design, balancing the need for robust security with the imperative of efficient and reliable network operation. Professional challenge lies in selecting a security implementation strategy that not only meets the technical requirements of the ENCOR syllabus, but also adheres to best practices for network management and compliance, without introducing undue complexity or performance degradation. The core of the decision-making process involves understanding the trade-offs between different security models and their impact on network visibility, troubleshooting, and scalability. The correct approach represents best professional practice because it prioritizes a layered security strategy that integrates security controls at multiple points within the network architecture. This aligns with industry-standard security frameworks and Cisco's own recommended methodologies for enterprise network security. By implementing security at the access layer, distribution layer, and core, and by leveraging technologies like network access control, NAC, and segmentation, the network becomes more resilient to threats and easier to manage. This approach ensures that security is not an afterthought but a fundamental component of the network design, leading to a more secure and stable environment. Furthermore, this approach supports compliance with general IT security best practices, which are implicitly expected in professional network implementation. An incorrect approach that focuses solely on perimeter security fails to acknowledge the evolving threat landscape, where internal threats and lateral movement are significant concerns. This approach is professionally unacceptable as it leaves the internal network vulnerable to breaches that bypass the perimeter. It also represents a failure to implement a comprehensive security posture, which could be a de facto violation of general IT governance principles that mandate defense in depth. Another incorrect approach that relies exclusively on endpoint security solutions, while important, is insufficient on its own. This is professionally inadequate because it neglects the network's role in preventing the spread of malware and unauthorized access. Relying solely on endpoints creates blind spots and assumes that all endpoints are perfectly secured and patched, which is rarely the case in a dynamic enterprise environment. This can lead to a failure to meet the expected level of network integrity and availability. A third incorrect approach that prioritizes a single, complex security appliance without considering integration with other network security controls is also professionally flawed. This can lead to a single point of failure, operational complexity, and difficulty in troubleshooting. It also fails to leverage the inherent security capabilities of various network devices and protocols, leading to a less efficient and potentially less secure overall solution. The professional decision-making process for similar situations should involve a thorough risk assessment, understanding of business requirements, and a deep knowledge of available technologies and their integration capabilities. It requires evaluating security solutions not in isolation, but as part of a holistic network architecture. Professionals should always aim for a defense-in-depth strategy, leveraging multiple layers of security controls, and ensuring that the chosen solutions are scalable, manageable, and align with industry best practices and any applicable general IT governance principles. Question 13. Benchmark analysis indicates that an enterprise network infrastructure is experiencing an increasing volume of sophisticated cyber threats targeting sensitive data and critical business applications. The organization requires a security strategy that not only mitigates these threats, but also supports the agility needed for rapid deployment of new services. Which of the following approaches best addresses these requirements while adhering to principles of robust network security and operational efficiency? Option A. Focus solely on strengthening perimeter security with advanced firewalls and deny all internal traffic by default, assuming that internal threats are negligible. Option B. Implement a comprehensive defense-in-depth strategy that includes network access control (NAC) for policy enforcement at the network edge, intrusion prevention systems (IPS) for real-time threat detection and mitigation, and network segmentation using VLAN and access control lists (ACL) to limit lateral movement of threats. Option C. Deploy endpoint security solutions across all devices and rely on user training to prevent security incidents, with minimal focus on network-level security controls. Option D. Implement a single, high-capacity intrusion detection system, IDs, at the Internet gateway and assume that all internal network traffic is inherently secure. The correct answer is B. Implement a comprehensive defense-in-depth strategy that includes network access control (NAC) for policy enforcement at the network edge, intrusion prevention systems (IPS) for real-time threat detection and mitigation, and network segmentation using VLAN and access control lists (ACL) to limit lateral movement of threats. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network design, balancing the need for robust security with the operational requirements of a dynamic and evolving business environment. The core tension lies in implementing security controls that are effective against emerging threats without unduly hindering legitimate network access or introducing excessive complexity that could lead to misconfigurations. The professional challenge is to select a security strategy that is both technically sound and aligns with the organization's risk tolerance and compliance obligations. Correct approach analysis. The correct approach involves a layered security model that integrates multiple security technologies and policies. This aligns with best practices in enterprise network security, emphasizing defense in depth. Specifically, the use of network access control (NAC) to enforce security policies at the point of entry, coupled with a robust intrusion prevention system (IPS) to monitor and block malicious traffic, and a well-defined segmentation strategy using VLAN and access control lists (ACL) to limit the blast radius of any potential breach, represents a comprehensive and proactive security posture. This layered approach is not only technically superior, but also aligns with general principles of due diligence and risk management expected in enterprise IT operations. While specific U.S. regulations like HIPAA or PCI DSS might mandate certain security controls, the ENCOR exam focuses on the technical implementation of these principles, which are universally applicable in enterprise environments. Incorrect approaches analysis. Relying solely on perimeter security without internal controls is a significant regulatory and ethical failure. It creates a false sense of security and leaves the internal network vulnerable to sophisticated attacks that bypass the perimeter. This approach fails to meet the standard of care expected in protecting sensitive data and systems. Implementing security without a clear policy or understanding of the business impact is also professionally unacceptable. It can lead to unintended consequences, such as blocking critical business traffic or creating security gaps due to incomplete implementation. This demonstrates a lack of due diligence and a failure to consider the operational context. Focusing exclusively on endpoint security without addressing network-level threats is another flawed strategy. While endpoint security is crucial, it is insufficient on its own. Network-level threats can compromise multiple endpoints simultaneously, and without network-based defenses, the organization remains highly exposed. This approach neglects a critical layer of defense. Professional reasoning. Professionals should approach network security design by first understanding the organization's business objectives, risk appetite, and any relevant compliance requirements. This forms the foundation for selecting appropriate security technologies and policies. A defense-in-depth strategy, incorporating multiple layers of security controls at different points in the network, is generally the most effective. This includes strong access control, threat detection and prevention, and network segmentation. Regular review and updates of security policies and technologies are essential to adapt to evolving threats and business needs. The decision-making process should prioritize a holistic view of security, ensuring that each component contributes to an overall robust and resilient network infrastructure. Question 14. The analysis reveals that a newly implemented enterprise network segment for sensitive financial data is experiencing intermittent connectivity issues with the main corporate network, impacting critical business applications. The network design mandates strict segregation of this financial segment from all other network zones, with only explicitly permitted traffic allowed. The current routing configuration allows broad connectivity between segments, relying heavily on firewall rules for traffic filtering. The IT security team has raised concerns about the potential for unauthorized data exfiltration due to this broad routing policy, even with firewall controls in place. The network administrator needs to reconfigure the routing to enhance security and ensure compliance with data segregation policies without disrupting essential business operations. Option A. Remove all routing configurations between the financial segment and the main corporate network, relying solely on a direct, high-bandwidth firewall connection for all intersegment communication. Option B. Implement route filtering on the edge routers of the financial segment to permit only specific predefined routes and traffic types to and from the main corporate network, while denying all other traffic by default. Option C. Reconfigure the routing protocol to a more permissive state, allowing all traffic between the financial segment and the main corporate network, and instruct the firewall team to implement more stringent access control lists. Option D. Disable the routing protocol on the edge routers of the financial segment and rely on static routes configured on individual hosts within the financial segment to reach the main corporate network. The correct answer is B. Implement route filtering on the edge routers of the financial segment to permit only specific, predefined routes and traffic types to and from the main corporate network, while denying all other traffic by default. Explanation. The analysis reveals a common implementation challenge in enterprise networks, ensuring secure and efficient routing of sensitive traffic while adhering to established network segmentation policies. The professional challenge lies in balancing the need for rapid troubleshooting and network visibility with the imperative to maintain strict access controls and prevent unauthorized data flow, especially in environments where compliance with data privacy regulations is paramount. The scenario demands a nuanced understanding of routing protocols and security best practices, requiring a decision that is both technically sound and ethically responsible. The correct approach represents best professional practice because it prioritizes the integrity and security of the network by leveraging the capabilities of the routing protocol to enforce policy at the network edge. By implementing route filtering based on specific security zones and traffic types, the network administrator ensures that sensitive data remains confined to its designated segments, thereby complying with data segregation requirements and minimizing the attack surface. This proactive security measure aligns with the principle of least privilege and demonstrates a commitment to safeguarding sensitive information, which is a core ethical responsibility in network management. An incorrect approach that involves broadly permitting all traffic between segments without granular control fails to uphold the principle of least privilege and creates significant security vulnerabilities. This could lead to regulatory noncompliance if sensitive data is inadvertently exposed to unauthorized segments, potentially resulting in data breaches and associated penalties. Another incorrect approach, which relies solely on firewall rules for segmentation, overlooks the role of routing in enforcing policy. While firewalls are crucial for deep packet inspection and application-level control, relying on them exclusively for network segmentation can lead to inefficient routing and a less secure network edge, as routing decisions are made without considering security context. This can also introduce complexity and potential misconfigurations. A third incorrect approach, disabling routing between segments entirely, would render intersegment communication impossible, disrupting legitimate business operations and failing to meet the network's functional requirements. This demonstrates a lack of understanding of how to achieve secure segmentation while maintaining necessary connectivity. Professionals should approach such situations by first clearly defining the security and functional requirements for traffic flow between network segments. This involves understanding the sensitivity of data, regulatory mandates, and the operational needs of the organization. Subsequently, they should evaluate the capabilities of the chosen routing protocols and network devices to enforce these policies at the most appropriate layer. A layered security approach, where routing policies complement firewall rules, is generally the most robust. Decision-making should be guided by a risk-based assessment, prioritizing the protection of sensitive assets and compliance with relevant regulations. Question 15. The control framework reveals a critical need to secure the routing infrastructure within an enterprise network. A network administrator has identified that routing updates are being exchanged between core routers using a routing protocol that lacks any form of authentication. This oversight could expose the network to route injection attacks, leading to traffic blackholing or redirection to malicious destinations. The administrator is considering several approaches to mitigate this risk while ensuring minimal disruption to ongoing network operations. Option A. Rely solely on existing network segmentation to prevent unauthorized access to routing protocol traffic. Option B. Focus on optimizing routing convergence times and ignore the authentication aspect for now, addressing it in a future, less critical maintenance window. Option C. Disable the routing protocol on the core routers to eliminate the risk of unauthenticated updates. Option D. Implement strong authentication mechanisms, such as MD5 or SHA-256, for all routing protocol updates exchanged between core routers. Correct answer is D. Implement strong authentication mechanisms, such as MD5 or SHA-256, for all routing protocol updates exchanged between core routers. Explanation. The control framework reveals a common implementation challenge in enterprise networks, ensuring secure and efficient routing protocol operation while adhering to evolving security best practices and potential regulatory compliance. The scenario is professionally challenging because it requires a deep understanding of routing protocol security mechanisms, the ability to assess the risk posed by different configurations, and the foresight to implement solutions that are both effective and sustainable. The pressure to maintain network uptime and performance can sometimes lead to shortcuts that compromise security, making careful judgment and a structured approach paramount. The correct approach represents best professional practice because it prioritizes a layered security strategy for routing protocols, directly addressing the identified vulnerabilities. Implementing authentication mechanisms like MD5 or SHA-256 for routing updates is a fundamental security control that verifies the integrity and authenticity of routing information, preventing unauthorized route injection or manipulation. This aligns with general cybersecurity principles of least privilege and defense in depth, which are implicitly expected in professional network engineering. Furthermore, by considering the use of newer, more robust hashing algorithms, the chosen approach demonstrates a commitment to staying current with security recommendations and mitigating known weaknesses in older protocols. This proactive stance is crucial for maintaining a secure and resilient network infrastructure. An incorrect approach that involves disabling authentication on routing protocols is a significant regulatory and ethical failure. From a regulatory perspective, many industry standards and compliance frameworks, e.g., PCI DSS for payment card industry, HIPAA for healthcare in the U.S., mandate the protection of sensitive network traffic and the prevention of unauthorized access. Disabling authentication directly contravenes these requirements by leaving routing information vulnerable to interception and modification, which could lead to data breaches or service disruptions. Ethically, network engineers have a professional responsibility to design and maintain secure networks that protect the organization's assets and users. Failing to implement basic security controls like routing protocol authentication is a dereliction of this duty, potentially exposing the organization to severe financial and reputational damage. Another incorrect approach, focusing solely on performance metrics without addressing the security implications of routing protocol configuration, is also professionally unacceptable. While performance is critical, it cannot come at the expense of security. This approach demonstrates a lack of understanding of the interconnectedness of network functions and the potential downstream impacts of security vulnerabilities. It represents a failure to conduct a thorough risk assessment and to implement appropriate controls. From an ethical standpoint, prioritizing speed over security can be seen as negligent, as it knowingly exposes the network to risks that could have been mitigated. A third incorrect approach, relying on network segmentation alone to secure routing protocols without implementing direct authentication, is insufficient. While network segmentation is a valuable security tool, it does not inherently secure the routing protocol traffic itself. Malicious actors who gain access to a segmented network could still exploit unauthenticated routing protocols within that segment. This approach fails to address the specific threat vector of routing protocol manipulation and represents a gap in the security posture. Professionally, it indicates an incomplete understanding of how to secure routing protocols and a potential over-reliance on a single security control. The professional decision-making process for similar situations should involve a systematic approach. 1. Identify the specific network components and protocols in question. 2. Understand the security implications and potential threats associated with each component and protocol. 3. Consult relevant security best practices, industry standards, and any applicable regulatory requirements. 4. Conduct a risk assessment to prioritize vulnerabilities and potential impacts. 5. Design and implement security controls that are appropriate for the identified risks, employing a defense-in-depth strategy. 6. Regularly review and update security configurations to adapt to evolving threats and technologies. 7. Document all security decisions and implementations for audit and future reference. Question 16. Benchmark analysis indicates that a new deployment of Internet of Things, IoT, devices is planned to integrate with existing critical enterprise network infrastructure. These IoT devices are intended to collect environmental sensor data that will be processed by existing systems. Given the sensitive nature of the data processed by the critical infrastructure, a key concern is to prevent any potential security vulnerabilities introduced by the IoT devices from compromising the existing network. What is the most appropriate network segmentation and security approach to implement for this scenario, adhering to U.S. regulatory frameworks for network security and data protection? Option A. Place all IoT devices on the same subnet as the critical infrastructure and rely on the inherent security of the existing network to protect it. Option B. Implement VLAN to logically segment the IoT devices, but configure a single, broad firewall rule allowing all traffic between the IoT segment and the critical infrastructure. Option C. Implement VLAN to logically segment the IoT devices from the critical infrastructure and configure access control lists, ACL, on the Layer 3 interfaces to permit only necessary traffic flows between the segments. Option D. Deploy the IoT devices on a completely separate physical network with no direct or indirect connectivity to the critical enterprise network, and no internetwork security controls. Correct answer is C. Implement VLAN to logically segment the IoT devices from the critical infrastructure and configure access control lists, ACL, on the Layer 3 interfaces to permit only necessary traffic flows between the segments. Explanation. Scenario analysis. This scenario presents a common implementation challenge in enterprise networks, ensuring secure and efficient communication between different network segments, specifically between a new IoT deployment and existing critical infrastructure. The challenge lies in balancing the need for rapid deployment and functionality of the IoT devices with the stringent security and compliance requirements of the existing network. Misconfiguration can lead to security vulnerabilities, performance degradation, or even regulatory noncompliance, impacting business operations and potentially leading to data breaches. The professional challenge is to select a network segmentation strategy that is both technically sound and adheres to established security best practices and relevant U.S. regulatory frameworks for data protection and network security. Correct approach analysis. Implementing VLAN and access control lists, ACL, is the best professional practice in this scenario. VLAN provide logical segmentation of the network, isolating the IoT traffic from the critical infrastructure. ACLs then act as granular firewalls at the network layer, controlling precisely which traffic is permitted to flow between the VLAN. This approach directly addresses the security and performance concerns by limiting the attack surface and preventing unauthorized access. From a U.S. regulatory perspective, this aligns with principles of least privilege and defense in depth, which are foundational for compliance with regulations like HIPAA for healthcare data or PCI DSS for payment card data. By minimizing the exposure of sensitive systems to potentially less secure IoT devices, it ensures that only necessary communication channels are open, reducing the risk of data exfiltration or lateral movement by threats originating from the IoT segment. Incorrect approaches analysis. Placing all IoT devices on the same subnet as the critical infrastructure without any segmentation is a significant regulatory and ethical failure. This approach violates the principle of least privilege and creates a broad attack surface. If any EOT device is compromised, the entire critical infrastructure becomes vulnerable, leading to potential data breaches and noncompliance with data protection laws. It is ethically irresponsible as it exposes sensitive data to unnecessary risk. Implementing a single, broad firewall rule allowing all traffic between the new EOT segment and the existing critical infrastructure, while technically segmenting with VLAN, is also professionally unacceptable. While VLAN provide isolation, a permissive firewall rule negates much of the security benefit. This creates a false sense of security and is a direct contravention of security best practices and regulatory requirements that mandate granular control over data flows. It increases the risk of unauthorized access and data exfiltration, making the organization susceptible to penalties under data privacy regulations. Deploying the EOT devices on a separate physical network, but without any internetwork security controls, like ACLs or a dedicated firewall, is an incomplete solution. While physical separation offers some isolation, it doesn't prevent malicious traffic from traversing if a connection is established. This approach lacks the necessary granular control mandated by many U.S. regulations for protecting sensitive information and could be deemed negligent in a security incident. It fails to implement adequate safeguards to prevent unauthorized access or data leakage. Professional reasoning. Professionals must adopt a risk-based approach to network design and implementation. This involves understanding the sensitivity of the data and systems involved, identifying potential threats, and implementing controls that mitigate those risks effectively. The decision-making process should prioritize security and compliance from the outset. When introducing new technologies like EOT, a thorough assessment of their potential impact on the existing network and data security posture is crucial. The chosen solution must demonstrate a clear understanding of regulatory requirements and industry best practices, ensuring that the network is not only functional but also secure and compliant. This involves a layered security approach, where segmentation, VLAN, is combined with access control ACL to create a robust defense. Question 17. During the evaluation of a new branch office deployment requiring secure and efficient connectivity to the main enterprise network, a network engineer is tasked with selecting and implementing an appropriate routing protocol. The primary concerns are to ensure routing stability, prevent unauthorized routing information exchange, and maintain optimal network performance without introducing excessive complexity. The engineer must choose a solution that aligns with enterprise best practices for network security and operational integrity. Option A. Enable IGAP without configuring any neighbor authentication. Option B. Configure static routes for all branch office subnets. Option C. Implement OSPF with MD5 authentication for routing updates. Option D. Deploy RIP2 without any authentication mechanisms. The correct answer is C. Implement OSPF with MD5 authentication for routing updates. Explanation. The scenario presents a common challenge in enterprise network design, balancing performance and security requirements while adhering to established best practices and potential regulatory considerations, even if not explicitly stated as U.S. federal law for this exam context. The core of the challenge lies in selecting an appropriate routing protocol for a new branch office connection that needs to be both efficient and secure, without introducing unnecessary complexity or vulnerabilities. The correct approach, implementing OSPF with specific security configurations, represents best professional practice because OSPF is a widely adopted, scalable, and efficient interior gateway protocol suitable for enterprise networks. The emphasis on security features like authentication ensures that routing information is exchanged only with trusted neighbors, preventing unauthorized modifications or injections that could disrupt network operations or lead to security breaches. This aligns with general principles of network security and operational integrity, which are implicitly expected in professional IT environments. An incorrect approach involving the use of RIP2 without authentication is professionally unacceptable due to its inherent security vulnerabilities. RIP2 is a distance vector protocol with limitations in scalability and convergence time, but more critically, it lacks robust built-in security mechanisms. Transmitting routing updates in clear text or with weak authentication makes the network susceptible to routing table poisoning attacks, where an attacker could inject false routes, redirecting traffic through malicious destinations, or causing denial of service conditions. This directly violates the principle of maintaining network integrity and confidentiality. Another incorrect approach, relying solely on static routes for all branch office connectivity, is professionally problematic due to its lack of scalability and dynamic adaptability. While static routes are secure in the sense that they are manually configured and not subject to dynamic protocol vulnerabilities, they become unmanageable in larger or frequently changing environments. The manual effort required to update routes during network changes increases the risk of human error, which can lead to connectivity issues or security misconfigurations. Furthermore, it fails to leverage the benefits of dynamic routing for efficient network convergence and load balancing. Finally, an incorrect approach of enabling IGP without any authentication is also professionally unsound. While IGP offers advantages in terms of convergence and scalability over RIP2, it still requires security measures to protect its routing updates. Without authentication, IGP-neighbor relationships can be established with unauthorized devices, potentially leading to the acceptance of malicious routing information. This compromises the integrity of the routing table and the overall network security posture. The professional decision-making process in such situations involves a systematic evaluation of network requirements, performance, scalability, security, available technologies, and their associated risks. A structured approach would involve 1. Defining clear objectives for the new branch office connectivity. 2. Researching and comparing suitable routing protocols based on these objectives. 3. Prioritizing security considerations for all protocol implementations. 4. Implementing chosen protocols with appropriate security configurations. 5. Thoroughly testing the implementation to ensure both functionality and security. 6. Documenting the design and configuration for future reference and auditing. Question 18. The risk matrix shows a high likelihood of a critical security vulnerability being exploited due to an unpatched network device, potentially leading to a significant data breach. The IT operations team is under pressure to resolve this immediately to prevent a security incident. Which of the following actions represents the most professional and effective approach to address this situation? Option A. Escalate the issue to senior management and request a temporary shutdown of the affected network segment until a permanent solution can be implemented. Option B. Reboot the affected network device to temporarily disrupt any potential exploitation attempts, deferring the patching process until the next scheduled maintenance window. Option C. Immediately apply the vendor-provided patch to the affected device after verifying its authenticity and planning for a potential rollback, while communicating the planned maintenance window to relevant stakeholders. Option D. Implement a temporary workaround by reconfiguring firewall rules to block traffic to the vulnerable service without applying the vendor patch. The correct answer is C. Immediately apply the vendor-provided patch to the affected device after verifying its authenticity and planning for a potential rollback, while communicating the planned maintenance window to relevant stakeholders. Explanation. The risk matrix shows a high likelihood of a critical security vulnerability being exploited due to an unpatched network device. This scenario is professionally challenging because it demands an immediate and effective response to mitigate a significant threat, balancing operational continuity with security imperatives. The pressure to resolve the issue quickly can lead to hasty decisions that might introduce new risks or violate established protocols. The correct approach involves a systematic and documented process of vulnerability remediation. This includes identifying the specific vulnerability, assessing its impact, planning the patch deployment with rollback procedures, communicating with stakeholders, and verifying the successful implementation. This aligns with best professional practices in network security and IT governance, which emphasize proactive risk management, change control, and incident response. Adhering to these practices ensures that remediation efforts are thorough, minimize disruption, and are auditable, thereby maintaining the integrity and security of the enterprise network. An incorrect approach would be to immediately reboot the affected device without proper planning or assessment. This could lead to an unplanned outage, impacting critical business operations and potentially causing data loss. Ethically and professionally, this bypasses established change management procedures, which are in place to prevent such disruptions and ensure that changes are controlled and understood. Another incorrect approach would be to ignore the vulnerability, assuming it is low risk or that the likelihood of exploitation is exaggerated. This demonstrates a failure in risk assessment and a disregard for security best practices. It exposes the organization to significant financial and reputational damage if the vulnerability is exploited, representing a serious ethical lapse in professional responsibility to protect organizational assets. A third incorrect approach would be to apply a workaround without addressing the root cause by patching the device. While this might offer temporary relief, it leaves the underlying vulnerability unaddressed, meaning the risk remains. This is professionally unsound as it defers a necessary security fix, potentially leading to more complex issues or a more severe breach later. It also fails to meet the standard of due diligence expected in network security management. Professionals should employ a decision-making framework that prioritizes risk assessment, adherence to established policies and procedures, such as change management and incident response, clear communication, and thorough documentation. This structured approach ensures that decisions are informed, justifiable, and aligned with organizational objectives and regulatory requirements, even under pressure. Question 19. Risk assessment procedures indicate that a new critical business application requires integration into the existing enterprise network. The application's vendor has provided specific network port and protocol requirements for optimal performance. However, the security team has raised concerns about potential vulnerabilities associated with some of the requested open ports, citing a recent internal audit that highlighted weaknesses in the current firewall rule set for similar services. The network engineering team is under pressure to deploy the application quickly to meet business deadlines. What is the most appropriate course of action to ensure both timely deployment and robust security? Option A. Implement the application with the vendor-specified ports and protocols, and schedule a follow-up review of the firewall rules to address security concerns after the initial deployment. Option B. Conduct a detailed risk assessment of the vendor-specified ports and protocols. Work collaboratively with the security team and the vendor to identify and implement necessary security controls, e.g., specific firewall rules, access control lists, or alternative secure protocols, and then proceed with a phased deployment. Option C. Deploy the application using only the ports and protocols deemed secure by the security team, and inform the vendor of the limitations, potentially impacting application functionality. Option D. Immediately implement the application with all vendor-specified ports and protocols, assuming the vendor has followed industry best practices for security, and defer any security reviews until a later date. The correct answer is A. Implement the application with the vendor-specified ports and protocols, and schedule a follow-up review of the firewall rules to address security concerns after the initial deployment. Explanation. The scenario presents a common challenge in enterprise network implementation, balancing the need for robust security with the operational requirements of a new service. The professional challenge lies in interpreting and applying security policies in a dynamic environment, ensuring compliance without hindering legitimate business functions. This requires a nuanced understanding of both security principles and the practical implications of network configurations. The correct approach prioritizes a thorough risk assessment and a phased implementation, aligning with best practices for network security and change management. This methodology ensures that potential vulnerabilities are identified and mitigated before a new service is fully deployed, minimizing the risk of security breaches or service disruptions. Adhering to established security frameworks and internal policies, which are implicitly governed by general IT best practices and potentially industry-specific regulations. Though not explicitly stated for this exam's jurisdiction, the principle of due diligence applies, is paramount. This approach demonstrates professional responsibility by proactively addressing security concerns and ensuring that the implementation is both secure and effective. An incorrect approach that bypasses or inadequately addresses security controls before deployment represents a significant regulatory and ethical failure. It demonstrates a disregard for established security policies and a failure to exercise due diligence, potentially exposing the organization to data breaches, service outages, and reputational damage. Such an approach could violate internal compliance mandates and, in a broader sense, fail to uphold the professional obligation to protect organizational assets and user data. Another incorrect approach, focusing solely on immediate functionality without considering security implications, is also professionally unacceptable. This demonstrates a lack of foresight and an incomplete understanding of the interconnectedness of network services and security. It can lead to the introduction of vulnerabilities that are difficult and costly to remediate later. A third incorrect approach, involving arbitrary security measures without a clear understanding of their impact or necessity, is inefficient and unprofessional. It suggests a lack of analytical rigor and can lead to overrestriction of network services, impacting usability and productivity, or, conversely, ineffective security that fails to address actual risks. The professional decision-making process for similar situations should involve a structured approach. First, thoroughly understand the new service's requirements and potential security implications. Second, consult and strictly adhere to all relevant security policies and best practices. Third, conduct a comprehensive risk assessment, identifying potential threats and vulnerabilities. Fourth, develop and implement a phased deployment plan that includes security validation at each stage. Finally, document all decisions, configurations, and risk mitigation strategies. This systematic process ensures that security is integrated into the implementation lifecycle rather than being an afterthought. Question 20. Regulatory review indicates that a network engineer has discovered a previously undocumented security vulnerability in a core Cisco routing platform deployed within their enterprise network. The vulnerability, if exploited, could allow unauthorized access to sensitive network data. The engineer has the technical expertise to exploit this vulnerability, but has not done so. The organization is under pressure to maintain high network uptime and performance, and reporting the vulnerability might lead to a temporary disruption during patching. What is the most ethically and professionally responsible course of action for the network engineer? Option A. Keep the vulnerability confidential and monitor network traffic for any signs of exploitation, hoping it remains undiscovered. Option B. Attempt to exploit the vulnerability to understand its full impact and potential for mitigation before reporting it. Option C. Immediately report the vulnerability to Cisco through their official security vulnerability reporting channels, providing detailed technical information, and work with Cisco to develop and implement a patch. Option D. Publicly disclose the vulnerability on a security forum to alert the wider community and pressure Cisco into a faster response. The correct answer is C. Immediately report the vulnerability to Cisco through their official security vulnerability reporting channels, providing detailed technical information, and work with Cisco to develop and implement a patch. Explanation. This scenario presents an ethical dilemma rooted in the responsible disclosure of security vulnerabilities within enterprise network technologies, a core component of the ENCOR exam. The challenge lies in balancing the immediate need to protect the organization from potential exploitation with the broader responsibility to contribute to the security ecosystem by informing vendors of flaws. The pressure to deploy a solution quickly, coupled with the potential for reputational damage if a vulnerability is exploited before a fix is available, creates a complex decision-making environment. The correct approach involves a structured and responsible disclosure process. This aligns with industry best practices and ethical guidelines that prioritize coordinated vulnerability disclosure. By reporting the vulnerability to Cisco through their established channels, the network engineer acts ethically and professionally. This allows Cisco to develop and distribute a patch, minimizing the risk to all users of the affected technology. This approach upholds the principle of responsible disclosure, which is crucial for maintaining the integrity and security of enterprise networks. It also demonstrates a commitment to the broader cybersecurity community by not exploiting the vulnerability for personal gain or allowing it to remain unaddressed, which could lead to significant harm. An incorrect approach would be to exploit the vulnerability for personal gain or to share it publicly without informing the vendor. Exploiting the vulnerability would be a clear violation of ethical conduct and potentially illegal, leading to severe professional and legal consequences. Publicly disclosing the vulnerability without prior notification to Cisco would be irresponsible and could lead to widespread exploitation by malicious actors, causing significant damage to the organization and others. This action would demonstrate a disregard for the principles of coordinated vulnerability disclosure and could result in a loss of trust from both the vendor and the employer. Another incorrect approach would be to ignore the vulnerability, hoping it goes unnoticed. This is negligent and fails to uphold the professional responsibility to secure the network. It leaves the organization and its users exposed to potential attacks, which could have severe operational and financial repercussions. The professional decision-making process in such situations should involve 1. Identifying the vulnerability and assessing its potential impact. 2. Consulting organizational policies on security incident reporting and vulnerability management. 3. Following established channels for responsible disclosure, typically involving direct communication with the vendor. 4. Documenting all findings and actions taken. 5. Prioritizing the security of the enterprise network while adhering to ethical and legal obligations.